In this beginner tutorial, I'll show you how to make a 2.5D top-down game in Unreal Engine 5. You'll learn how to set up multi-directional sprite animations, top-down character movement using the enhanced input system, and how to make your 2D top-down games look awesome by mixing them with 3D environments and Unreal Engine's modern lighting. I already made a video about this topic roughly 2 years ago, which was very well received, but a couple of things have changed and I found many workflow improvements that I want to show you. Feel free to use the chapter selection to skip over parts you already know, and let's get right into it. Now I'm gonna use Unreal Engine 5.5 for this, but this video should be valid for multiple years. There's probably not gonna be a lot of changes, and you can also follow along with newer versions. And in the project browser, we wanna make a game, of course, so click on Games. And you can see I have a couple of custom templates here for 2D and 2D 3D hybrid games. This one is free for everybody and open source, and these are just for patrons. You can find a link in the description how to get them, but we're gonna start from blank here because I wanna show you everything step by step. So make sure to select blank. It's a blueprint project. You don't have to change these settings here. Just leave it as is, no starter content, and then give it a name. I'm just gonna call it hybrid top down and click on create. After Unreal Engine has opened up, you're gonna see this open world map, and of course we can make these 2D 3D hybrids in open world maps, but for the sake of simplicity for this tutorial, we're gonna use a smaller map. To create a new map, we can just click on File, New Level, and then we're going to use the basic level because we do want to have some lighting. We do want to have a sky box, a sky sphere. So click on create. And then I want to save this map so we can use it later in case we shut down Unreal Engine. So save current level. Inside the content folder, right click, make a new folder called levels, open it up, and here I'm just going to call it L for level underscore playground, because this is where we're going to test our character, and click on save. And the next thing we have to do is import the sprite sheets for our characters. And I'm going to use this asset pack by Axial Arts, which I can redistribute under a Creative Commons attribution license. We're actually not going to use the assets from this page because I recolored and repackaged them to be easier to use with Unreal Engine. So if you want to follow along step by step, make sure to download them from the link in the description. They're hosted on Patreon, but you don't have to be a member and everybody can download them. After doing that, you should get this zip file called top-down tutorial, and we just want to right click and unpack it. So extract all, and just extract here. Then double click the folder, not the zip file, very important. And we have a couple of different assets in here. So we have the kid pink, and you can see we have a PNG file, and we also have a JSON file, and the JSON file makes it even easier to import this into Unreal Engine. And I also have kid red, and you can just pick whichever one you prefer. I'm going to use kid red. Now we could just import the PNG file and manually extract the sprites and then create the flipbooks manually. But as I said, the JSON file already has everything cut for us, already has the flipbooks and everything set up for us, and I prepared this. If you want to know how to create a JSON like this, there's another video I did in the past you can check out. But now let's just prepare a folder to drag this into in Unreal Engine. So here in the content drawer, I'm gonna be in the content folder, right click, and create a new folder called Paper Assets. Inside of here, I want to create another folder, new folder called Kid Red or Kid Pink, whichever one you're gonna use. And then I just want to drag the JSON file only, not the PNG, in here, and the JSON is going to grab the PNG automatically. So here, just the kid red JSON, drag it into Unreal Engine and let go, and you should have these 3 files. In case dragging and dropping doesn't work for you, that's probably related to your operation system settings, so you can try to use the import button instead, which solves this issue for many people. And now all we have to do is right-click this sprite asset and create flipbooks. So we just saved ourselves 20-30 minutes setting all of this up manually. As you can see, we have 8 directions of sprites for every animation here. So this is the idle animation, we have 8 sprites, and it is just a single frame. You don't have this bobbing up and down that many animations have. And well, both of these solutions are valid. This is just a still frame. And then you can see here we have the walking animations, again with 8 directions. One thing we cannot set in the JSON is the playback speed, the FPS setting for these flipbooks, so let us adjust that a little bit. Let's just open up any of these walk animations by double-clicking it, and this gives us the flipbook editor. And here on the right side you can see the frames per second setting, and now it's 15, which is quite fast, and we can set it down to, let's say, 3 just to see how slow it is now, but this is too slow, so I think a value of 5 is about right. And now we want to apply this to all of the other animations. And well, it is a little bit cumbersome if we click on the content drawer here to just manually do this for every single flipbook. So I just want to select all of them, click the first one, hold shift, click the last one, and then I can right click any of them, go to Asset Actions, and we have the Edit, Selection, and Property Matrix. In earlier versions of Unreal, I think this was called Bulk Edit, but just click it, and it gives us this nice editor window where we can change the properties of multiple assets at once. Now on the left side, we want to click any of these, Control A to select all of them, and then here on the right side, we can just open up this menu, and you see the frames per second where it says multiple values. And here, we just want to delete this and override it with the value of 5. And then make sure to save, and all of these assets are now set to 5 frames per second. And you can see when we hover that it has the slow walk that we set up for the first one, and now it's applied to every asset here. Now that we do have our animations here, we have two choices. We could implement the switching of the animations and the directions manually in the blueprints, and this is something I cover in my course, but it is quite cumbersome and hard to expand. What we're going to do for this video is use the free PaperZD plugin, which is an Epic Mega Grant recipient. It comes with many great features such as an animation blueprint for 2D characters, the ability to play particle effects or events on certain frames of an animation, and most importantly for this video, it has a multi-directional animation tool. And this lets us set up and control these multi-directional animations here much easier than doing it by hand. Now, if you've already used PaperZD in the past and already have it installed, all you have to do is go to Edit and Plugins and look for PaperZD and then turn it on and restart the engine. You might be asked to save, and in that case, save everything. And after Unreal Engine restarted, you're ready for the next step. But if this is your first time using PaperZD, I'm going to quickly show you how you can install and activate it. First, we need to shut down Unreal Engine or the plugin won't be recognized. Then you can go to Fab, here the Fab tab, and start exploring. Fab is the new Unreal Engine marketplace. And on here we can just search for PaperZD, no space in between, everything written together, and you should be able to see this PaperZD tools and plugin here. I will also put a link in the description just in case you can't find it. Here you should then be able to click on Add to my library, which isn't shown for me because I already have it. That should then attach it to your account. Once you've done that, you can go back to the Epic Games Launcher, go to Library, and at the bottom where it says the Fab Library, we can now look for PaperZD. If you've just added it, it might not show up and you have to click this refresh button and wait for a second. And after that's done, you should see the PaperZD plugin here and click on Install to Engine and select whichever engine version you're currently using and following along with this tutorial, and then just click on Install. You should see a little progress bar here, and once that is done, you can just open up the project again, in our case the hybrid top-down that we're currently working on. And now we just go to the Plugins tab here and look for PaperZD, and in your case it's probably off, so turn it on, and then click on Restart Now, and then you should be at the same stage that everybody that already had the plugin was in before. Okay, now everybody should be on the same page. Let's keep on going. We're now back in the open world map, so make sure to go to the content drawer, go to our levels, and open up our playground again. And now we can start working on our animations here. First, I want to create a new folder, so go to Content, and here right-click, New Folder, call it Blueprints, and double-click to open it up. And here, I'm going to make a new folder for Kid Red, which we're going to use, open it up. And yeah, so here we're going to later put in our character blueprint. We're also going to put in our animation blueprints, our animation sources, and everything regarding PaperZD for this character. Now that PaperZD is active, if you right-click anywhere here in the content drawer and scroll down, you should see this PaperZD menu. And there's 3 different asset types which we can create. So these are animation sequences. So these are singular animations that we can then play in the animation blueprint. We have the animation source, which lets us specify our multi-direction animations, also animations in general, the events we want to play. And then we have the PaperZD animation blueprint, which is quite similar to the animation blueprint you would get with 3D skeletal meshes. And it lets us control what animation should play when, and also we can add additional logic here. The first thing we always start with is the animation source. And I'm going to call this AS for animation source _ Kid Red, and double click to open it up. Here we register all of our different animations, which we can then use, as I said, in the animation blueprint. For this character, that's quite simple because we just have an idle animation and a walking animation. What makes it complicated are the multiple directions, but this PaperZD plugin makes it very easy. First, let's click on Add New here and add a new animation sequence, and I'm going to call it Idle. In case this wasn't highlighted, you can just right click and rename as well and call it idle, and then double click to activate it. And now here on the right side, we can set up a few things. Now for a regular non-multidirectional sequence, we would just use the animation data, and let's just pick idle down for now. And you can see in here we have the character now, but we do want to use a multi-directional sequence. So we can just click here to activate it. And this little menu makes our life so much easier for these kind of top-down games. We basically have two different settings here. We have the amount of directions, so by default it is 4, so that would be left, right, up, down. And we have the angle of directions. So in our case, we don't need to change the angle because we just look at the character from the front. But if you have a tactics style game, you would probably want to use a 45-degree angle or an isometric game, but we just leave it at 0. In our case, our character, if we open up the content drawer and go back to our paper assets kit red, well, you can see we have 8 directions, right? So default is 4. We want to change this to 8 to let us fit in all of the different directions that we have. And now we have this nice menu. We can click in these different directions, and let's start from the top. Now, since we played around with this, we already have the down direction here, but we actually want to set up the up direction for upward. So we can just click here, the animation node, and we look for our idle. I can just type in idle, and we have the idle up animation here, idle underscore U, and the character is looking upward. And now let's just do this clockwise. Upright, I can just look for UR and idle UR. Right, I can again just look for idle or R, and we have the idle right. Then we have down right, I can look for DR, but actually it's only highlighting it here, idle DR. And then we have down, I can again look for idle down here. Down left, I can put in DL, and we can see idle DL is being highlighted. And then we have left, I can look for idle again, idle left. And we have up left, UL for idle up left. And now we set up everything for the idle animation. And just to confirm that everything's set up correctly, we can hold shift and then drag around, and you can see the character is moving with our cursor here. And we just check that there's no like flickering pixels, that we didn't select the wrong animation. And this is the part where you could then make adjustments to your art if something doesn't look right. And by creating the animation sequence here, if we open up the content drawer, you can see that if we go back to content, blueprints, kit red, we have this animation sequence folder now, right? So we don't have to right click and create these animation sequences one by one. Just by creating one in here in the animation source, it creates this new asset for us, which we can then use throughout our blueprints, throughout the animation blueprint, and many different other places. Now let's do the exact same thing for the walk animation. It works just the same way. So add new, and here I'm going to call it walk, like this, double click, make sure it's a multi-directional sequence, set the amount of directions to 8, and then start at the top. I can look for walk, and I have a walk upward, then I have up right, a walk up right, then right, go for a walk right, down right, not idle down right, but walk down right, and we have down, so walk down here, and down left, not idle down left, but walk down left. And the next up, we have walk left here, and have up left, walk up left, and that should be it. Again, hold shift, just confirm that everything is working here. We didn't accidentally pick the idle animation anywhere, and yes, this looks fine. We also don't have any pixel flickering, there's no mistakes I made when recoloring the art. Something we're not going to use in this tutorial, but I want to show you, is the notifies window down here. So this is where we could play a sound or play a particle effect, or also trigger events like a hitbox, activating it, deactivating it. And this is just another benefit of PaperZD. But now we're done with our animation source, we're done with our animation sequences, we can just close this down. And well, the last missing part with PaperZD is the animation blueprint, but we're not going to create it just yet. We first want to set up the blueprint for the character and then use the animation blueprint together with it. And the whole reason we set up this animation source, the animation sequences, is so that we can use them together with the animation blueprint and then with our character blueprint. And now it's time to create our character blueprint, and this is going to be the actor that we, the player, are possessing, and we can change all the different properties, we can change which sprites it should use, and we can also implement our logic for the gameplay, for the movement, and everything in here. So this is the heart of our project. So back in the content drawer, we want to go to the content folder, go to blueprints, kid red, and inside of here right click and create a new blueprint class. And if you've been using Unreal for a while, you probably know what you're supposed to do here, but if you're new, this allows you to pick the parent class of the blueprint. And this means we can derive our blueprint from different other blueprints and reuse and update their functionality. So for example, we could have a character which already is a type of pawn. It has the ability to walk around and many of these functionality that we don't have to make from scratch. We don't have to reinvent the wheel. A game mode, for example, which we're also going to use, sets up the rules of the game, score, and these kind of things. But what we want to use is very similar to a character, but we want to have a sprite-based character. So it's not this one, but we can actually go to all classes and we can look for paper. And you can see we have the pawn character, PaperZD character. So this means the PaperZD character has everything the paper character has, which is everything the character has, which is everything the pawn has. And then they have their own kind of layers of functionality, layers of properties on top of that. And in our case, because we are using PaperZD, we want to use the PaperZD character, which already has everything set up that we want to use for this project. Just select it and also click on select down here. And I'm going to call this VP underscore kid red and double click to open it up. Now, the only real difference between the PaperZD character and the paper character is that we have this animation component. This comes from PaperZD. It lets us specify which animation blueprint we want to use, so it can then take over and control the sprite, the flipbook for us. Outside of that, well, we have the capsule component, which characters use to collide with the world, collide with other characters. The arrow just shows the direction. And the sprite, well, technically, if you hover, this is a flipbook component. This is not a sprite, this is actually a flipbook, and the naming can be a little bit confusing here. And then we also have the character movement component, which makes implementation of character movement very easy. So we don't have to code it from scratch, we simply say add movement input and the direction and the strength, and then we can start walking around in the world. The first thing I want to do just to visualize things is to go to the sprite or the flipbook component, and we just want to select any of the frames of our character. So let's just say the idle down. And this lets us adjust the size and everything for the character because you can see it is very, very small right now. And actually I have to zoom in, hold right click and zoom in for you to be able to even see the character. Now there's two ways we could handle this. We could either make the capsule smaller to match the sprite or make the sprite bigger to match the capsule. And this is actually the correct solution. Because all of these settings on the character movement component, they kind of expect our character to be of a reasonable size. So things like the gravity, the step height, and speed, walk speed, everything, all of those expect your character to be somewhere between, let's say, 1 meter and 2 meters tall with the default settings. And all of the map assets you're going to find on the marketplace are kind of made for this size. So it is much better to make the sprite bigger rather than make the capsule smaller. Now, just to get an idea of the size that we want, we can lock this scale here so we can change the XYZ all at once. And we can just play around with a couple of values here, let's say 4, make it 4 times bigger. It's not quite enough. And let me try 8 times, make it 8 times bigger. And yeah, so this is about right. It doesn't have to be perfect, just kind of in the same ballpark. And it's totally fine for the ears and the hands to be outside of the capsule here. But changing the scale in this window is actually not ideal because it's only going to change the sprite scale inside of this one blueprint, not across all of the other editor windows in Unreal Engine. And this could lead to problems with how it's being displayed. It makes it easier for you to make mistakes and create mixels where pixel sizes are different for different assets, and we don't want that. So a better way is actually to change the pixel per unit setting on our sprite. Now just make sure to remember the 8 times because we're going to use this number in the pixel per unit setting. And we can just open up the content drawer, go back to our paper assets, go to kid red, and now texture the frames folder, go into the frames folder, click any of these, Control and A, so we can select all of these. And again, we're going to edit them in bulk. So right click, and it might ask you if you want to load these assets. Yeah, it's fine to load them. And then go to Asset Actions and edit Selection in Property Matrix. And this is the same one we used before for the flipbooks, but we can also use it for sprites. And here again, click any, Control A to select all of them, and we can just look for pixels, and we have the pixels per unit setting. And I said remember the 8 times bigger. Well, here we have to use this number, so 1 divided by 8, because it's inverted, the pixel per unit. So 1 divided by 8. You can just do the math right here, hit enter, and it gives you 0.125. And this basically means that 1 pixel in the world is 8 centimeters. And we can just save, go back to our blueprint, and now the character is really big because we're using the pixel per unit and also using the scale. So now that we have the pixel per unit, the scale, we can just go back to 1. And now you see we have the same size, but we're using the pixel per unit, which is more stable, which is a better practice, the best practice to use for this. Now we do want to align the position of the sprite here in the vertical axis, because you can see below the feet, we have a little bit of leeway here. And just to show you what happens here, let me drag this over here. In the playground, I just want to drag in an instance of the blueprint. So content, blueprints, kid red, and we have the BP kid red. I'm just going to drag out an instance, and you're going to see we are floating above the ground. And this is, of course, not what we want. So in the kid red, we want to adjust the position of the sprite. And well, we could just drag it around and try to find the right value. But it would be easier if the pivot point you see right here is not in the middle, but if the pivot point was at the feet, that makes it a little bit easier to figure out the position. And to do that, again, we can open up all of our sprites. So content, paper assets, kid red, frames, again, open all of them. At this point, you know asset actions, selection property matrix, select all of them and look for pivot. And here we can see pivot mode. By default, it's center, center, but you can use custom. You can use a lot of different settings here. We want to use bottom center and hit save. And you can see now in the blueprint, the pivot is right at the feet, and this just makes it easier to position the character. So first, I want to make the capsule a little bit smaller. Like I said, we don't want to change it too much, but we can make slight adjustments. So the capsule component, not 88, but let's say 70 for the half height, and this matches the character better. And 70 for the half height means 140 for the entire height of the capsule, and this is 140 centimeters, which is a reasonable size for Unreal Engine, and it is also a reasonable size for a kid of this age. Now we can go back to the sprite, we can remember this 70, and well, we already are exactly at minus 70, so I got lucky dragging it here, but we could just type in minus 70, and this would give us perfectly this position of the capsule. Well, but let's see how this works out in the game. So in the game, I want to drag this instance of the blueprint upward, and I want to have physics act on the character to see if we actually are in the perfect position or not. To do that, I can just click not on the play button, but click on simulate. And you can see the character falls down. To make it a little bit easier to see, I can drag up more. And if we click on simulate now, you can see the character is falling down and hitting the ground. And now I can just zoom in here, use the mouse wheel to slow down the zoom so I can get very close to the character. And we can then see that there is actually a small gap between the feet and the ground. So just making it line up perfectly in here is actually not enough. We have to do some slight adjustments here if we want to have the perfect position. So what we can do here is go to Kid Red and select it, and then here in the details panel, go to the sprite, and we can make some adjustments here. For example, I can just type in minus 72 to go down a little bit more, and then zoom in to see, and we still have a little bit of a gap, do we? Maybe try minus 72.5, and let's see here, and this looks perfect. There's no gap, we are exactly on the ground. But now we just made these changes to the instance of the blueprint, so this one instance in the world. But we also want to change the blueprint, which I guess is the mold for creating these instances, to also use the minus 72.5. So I can just quit out here, go back to the BP Kid Red. On the sprite, now I use minus 72.5 instead of 70, instead of minus 70. And now I can just click on simulate again, and the character is going to fall down. And we can see here that we are perfectly aligned with the ground. Now we have this instance in the world, our sprite is set up correctly, but the character doesn't really look like it fits into the world because it's not receiving shadows, it's not casting shadows, so we just want to change a couple of settings that we always have to change for these 2.5D games in Unreal Engine. The first thing I want to do is make this sprite cast a shadow. And we could just change this here in the instance, but as I said, we want to change this in the actual blueprint, which is going to affect all of the instances in the world. So we can go to the sprite, we can look for shadow, and we just have to tick cast shadow. That is all we have to do, and you can see we get this shadow on the side. Now this shadow doesn't look all that interesting. And I'm going to go over here and I want to change the direction of the sun. So I can look here for direction, directional light. I can go into rotate mode by clicking here or hitting E on the keyboard. And then on the blue axis, I can just drag around. And I want to have the shadow behind the character, kind of diagonal behind the character like this. Now, the next issue you're going to notice if, let's say, we change the time of day, so I can drag on the red axis to give it a longer shadow. But if I go into night, you can see that the character is basically acting like a flashlight. It is self-illuminating, which is something we don't want for these 2D, 3D hybrids. So I can just drag back up here and yeah, something around this, let's say. And this is related to the material. This is actually not the only issue. The character also doesn't receive shadows. It doesn't receive lighting information right now. To demonstrate that, let me get back into movement mode, translate mode, and I'm going to add a block here. So click on plus, shapes, and just add a cube to the scene. And I want to drag it in front of the character like this. And you can see it casts a shadow on the floor, but it doesn't cast a shadow on the character. In a similar way, I can add a point light, go to plus again, lights, point light, drag it kind of in front of the character like this, off to the side, and maybe change the color to red to make it more visible. And again, you can see it affects the floor, it affects everything around it, but it doesn't affect the character sprite. Now, all of this is related to the material setting on the character, which we can very easily update. So I'm going to drag this over here so you can see what happens in real time. And in the character blueprint, I go to the, let me make this bigger. I go to the sprite, and here on the right side, I'm not going to look for shadow anymore. I'm actually gonna go for the material. So you can see here, scroll down, material element 0. And now we are using the masked unlit sprite material. We want to use the masked lit sprite material. And the naming can be confusing, but unlit basically means it's self-illuminating. It's using the color it was drawn in, or at least trying to. And lit means it takes in shadows, it takes in lighting information from the scene. Now, if it doesn't show up for you, you might want to click on the cogwheel and make sure that show engine content, show plugin content is enabled. And then we can look for the masked lit sprite material and pay attention to the character. And now it changed. You can see if I close this down again, drag it here, you can see that we take information from the light is affecting the sprite, and in the same way, the shadow of the cube is affecting the sprite. And this is just the most important setting that you want to set when you make a 2D3 hybrid game like this. Now that this is working, I can just delete the cube. I can just hit delete on the keyboard when it's selected. Same for the light, hit delete on the keyboard, and here I can go out of the directional light search. By the way, if you've been enjoying this tutorial so far, I guarantee you'll love my course since it teaches you how to create 3 different top-down games with Unreal, covering things such as dialogue, NPC behavior, and even combat. You can get it at a huge discount from the link in the description. Next up, we want to possess the character and set up the camera. Right now, if we click on play, we aren't inside of the character, we just control this flying cube, and well, we want to possess this character and control it. But actually, the better way of doing this is to let Unreal Engine spawn the character for us. So I'm just going to click this instance of the blueprint, delete it, and you can see we have this player start that comes with most levels, and Unreal Engine knows that, hey, this is the player start. The player will want to be spawned in this location, and letting Unreal Engine take care of this in most cases is the safer way of doing things. To tell Unreal Engine what kind of character we want to have spawned here, we can create a game mode blueprint. So in the content drawer, we want to go to content, go to blueprints, and here right click, create a new blueprint class. And like I said before, this is the game mode base. So this holds the rules of the games. It holds default settings like the default setting for the pawn that we want to possess and all of these kind of things that we need. So we can just click here game mode base, and I'm going to call GM underscore top down and double click to open it up. And as you can see, this is a regular blueprint. So you could do logic in here, you could add variables, all these kind of things. But all we care about now is to go to the right side here to the classes. And these are the default classes. We want to change the default pawn class from the default pawn, which is this kind of floating orb with the camera we've got now, to our BP Kid Red. So Unreal Engine knows this is the one we want to spawn. But we also have to tell Unreal Engine to use this game mode because your project could have multiple game modes like Call of Duty, which has multiplayer, zombies, and we need to kind of tell it which one we want to use by default. Go to Edit, Project Settings, and here Maps and Modes. For the default game mode, we want to change it to use GM Top-Down, which we just created. And while we're at it, we can also change the default map from the open world map to our L_playground, and also the game default map to L_playground. This is the one that opens if we open up Unreal Engine, and this is the one in a packaged build that is the first map that starts for your players. Now, when we go back to our map and start the game, you cannot see it, but actually we are spawning in the BP Red character. So BP Kid Red, you can see it here on the right side, is being spawned in, but why can't we see it? The problem is that we still haven't set up a camera, so to get a better understanding of what's happening here, if you already clicked into the viewport, you can hit Shift and F1 to get your mouse pointer back and click on Eject, and now right click and WASD controls, like a first person shooter, you can zoom out and you can see, yeah, we were inside of this character, but because we didn't set up a camera, it just defaults to this first person camera, which is of course not what we want to use. But this proves that we are spawning the character and we are possessing it, so that is one step in the right direction. And now we can exit out here, and we want to set up the spring arm and the camera for our BP Kid Red. We want to make sure to attach the spring arm to the capsule component, so select the most top level thing here, add and look for spring arm. And the spring arm, it just helps us with positioning so we don't have to move the camera directly. And while the spring arm is selected, add the camera, and we have the camera, cine camera, gameplay camera. For our purposes, the regular camera is best. And the first thing we want to do is change the angle, so we're looking, while we have the spring arm, we're looking at the character from the front. I can go into rotate mode, and on the blue axis, I want to drag over like this by minus 90 degrees on the yaw, so we're looking at the character from the front. But something that might happen due to floating point errors is you get the minus 89.9999 instead. And if that drives you crazy, you can just put in minus 90 manually here on the z-axis. Now, if I start the game and the map, you can see we are looking at the character through our camera, and this is what we want. But it is a little bit too close. Back in the blueprint, we can go to the spring arm, and now we have this target arm length setting here. Now you can just use some trial and error here to find the right value. I like 650 for this kind of game, and you can see the camera moved backward. The spring arm just makes it a lot more comfortable than manually moving the camera around. And now I start the game. We have a nice little distance to the character, but well, this is not a top-down game. This looks very much like a side-scroller now, so we also want to change the angle of the spring arm and the camera. In the blueprint, we can go back to the camera. On the green axis, we can drag around, and well, you probably want to use something between, like, let's say minus 20 and minus 40 degrees. And like I said, we're not going to do a full minus 90 degrees for this game because it is a 2D/3D hybrid. We want to show more of the world. We want to make it a little bit more modern. So we're going to use a low angle between minus 20, minus 30. And I actually want to type it in manually here on the y-axis. I want to type in minus 25. And yeah, so now we get this minus 25-degree angle here. And look at it from the top. So this is more of a Octopath Traveler style top-down angle rather than a, I guess, true 90-degree top-down angle. And now we are possessing our character. We have the proper camera setup, but well, even if I click into the viewport to activate it, if I press buttons, well, nothing is happening because we have to set up the input mappings for the character. And then we have to set up walking, jumping, all of these things. To do this, we're going to use the Enhanced Input Action System, which was introduced with Unreal Engine 5.1. The legacy system was a lot easier to understand and set up, but it had a lot of limitations, with the new system being very robust, very solid once we went through the pain of setting it up. But let's get right into it. So in the content drawer, go back to the content folder here, right-click, make a new folder called Input, double-click, and here we want to have another folder called Actions, like this, and open it up. So for the input action system, there's basically two different component types that we have to create. If I right click and go to input, you see we have the input actions and the input mapping context. The other ones aren't related to this system. What we want to do is create an input action for every action our character can do. In our case, we just want to have move for moving and jump. Those are the two actions we want to create. And then after that, we have to bind them in the mapping context. Let's start with the jump because it's the simpler one. Create a new input action called IA underscore jump and double click to open it up. There are a bunch of settings in here that we can change, but the only one we really care about is the value type. And here we can pick between digital bool, axis 1D, axis 2D, and axis 3D. Well, a jump button can either be active or not active, so just pressing a button, and for this digital bool is correct because it could only be true or false that the button is currently being pressed. So just select digital bool and we can close this down. For the movement, it's a little bit more complicated, so right click for the input, input action, and it's called IA underscore move, and open it up. In this case, we actually want to use an axis 2D, and why is that? We want to have two different values that are being output for the horizontal axis, so left and right, and another value for up and down. And these values should be between -1 and 1, minus being left or up, and plus being right or down. And the axis 2D is great for this because we can use it for WASD keyboard controls, we can use it for the D-pad on the controller, and we can also use it for the analog stick, so every case is covered by this. Axis 1D, for example, would be something like a trigger on the controller that can be pressed partially, so you get a value between 0 and 1. Axis 3D would be a VR controller, a motion controller, for example, that can move freely in 3D space. So for us, axis 2D is the one we want to go to. And that's it for this asset. We can close it down. And now we just want to create the mapping context. So go back to the input folder, right click, go to input, and here the input mapping context. I'm going to call it IMC, input mapping context, and top down. And double click to open it up. And like I said, we want to now bind every action that we created to a button, and then we can change the modifiers, we can change the triggers to make it work the way we want it to work. Click on plus, and let's open up this menu. And first, I want to take care of the IA jump because again, it is much simpler than the move. We again have to open up this menu, and here we can now set up the buttons that we want to use for jumping. And I can just click here and activate it, and now I press the spacebar and it registers the spacebar as a button to jump. And we could also have multiple ones. I can click here again and then click here and let's say enter. So I can jump on both space or enter. And in the same way, if you have a controller connected, you could press the A button on your Xbox controller or a PlayStation controller, whatever you have connected to Unreal Engine. And that's pretty much it for jumping. But moving is going to be a little bit more complicated. Let's click here and add the IA move and open this up. And we're going to start with the right direction. For a vector 2D, right is the default direction. So plus on the horizontal axis is default. I can just click here and I'm going to use WASD controls. You could use the arrow keys if you wanted to. I'm just going to use D for right. And since right is the default direction, we don't have to change anything. But this is going to look a little bit different for left. We can click here to add another input. And here I want to use A for WASD left controls. Now in this case, D, if we press D, it gives us the value of +1 on the horizontal, but also A is going to give us the value of +1 on the horizontal. We want it to give us the value of -1. And to do that, we can go to the modifiers and we can simply look for negate. So here we have the negate and you can see it inverts input per axis. This is great. So now when we get +1, we know it's right. If we get -1, we know it's left. And now we also want to do up and down. For vertical, downward is actually the default. So we want to start with down or S on the keyboard. And well, we now have again the horizontal positive axis by default. So we want to go from the horizontal to the vertical axis now. So on the modifiers, we just look for swizzle and you can see swizzle input axis value. So this just lets us map the value on the y-axis instead. And now we have the +1 on the y-axis. And you might think that downward being positive is weird, but I'm going to get into the details of that later. It's actually correct here. And lastly, I want to go upward. So add another input, W for up. And here we have to change two things. We want to change the axis to the y-axis, and we also want to negate it. So here again, modifiers, I can just click twice to add two, look for swizzle, use the swizzle input axis values, and then also negate. So now we change two things. We change the axis and we negate the value. And this is all we have to do in here. But we need to register this input mapping context on our character. So in the BPKit red, we go to the event graph And this lets us implement the blueprint logic, the logic of our game, the inputs, the controls, and everything we can do in here. Begin play fires off either if the game has just started or if there's an instance of this bpkit-red that has been spawned. So we can use this to set up our input bindings. What we can do here is right click and we can get controller like this. So this is the controller asset, the controller actor that is connected to the spawn. And we want to make sure it's a player controller. So cast2 player controller, and connect these lines here to make sure the execution is actually happening. And then we can use the casted player controller to access the subsystem. And you can see we have the get enhanced input local player subsystem, right? So you don't have to understand everything that is going on here. This is quite advanced, but you just have to memorize it for the sake of setting up the input mapping context. And here we can then add mapping context like this. And again, make sure to connect it if the cast was successful. And very important, don't forget this, on the mapping context asset, we have to select our IMC top-down, which we created. And you could add multiple mapping contexts, right? So the mapping context, for example, would be something in Grand Theft Auto. You have the walking mode, you have different controls, different settings for the walking mode and the driving mode. And you could then activate or deactivate these mapping contexts based on what is happening in the game. But for us, we just have one top-down context, very simple. And this enhanced subsystem exists on the player controller. This is why we get the controller that is attached to this pawn, and then we cast it to the player controller because this is where it exists. And now that we have this connected, these two, we can start implementing the jump. So here I can right-click IA underscore jump and have this enhanced action events, have the jump, and I can open this up so we get access to everything that we can get from here. Now this can be a little bit intimidating, but we don't need to use all of these. For jumping, what is important, we don't want to use triggered. Triggered always fires off while the button is being held, but we only want to jump one time when we press the button. So here from started, we can just call jump. And this is a function, a method that Unreal Engine has prepared for us on the character. And this is possible because, well, we inherited from the PaperZD character, which inherited from the character, which inherited from the pawn, and we also have access to this character movement component. And again, we don't have to reinvent the wheel. This jump function Unreal Engine gives it to us and we can use it. And you can also see in the tooltip it says we can call stop jumping on completed. So here we can just call stop jumping like this. So if you let go of the button, it's not gonna keep on going for variable jump heights and things like that. And now if I go back to the game, I start the game, very important, click into the viewport, otherwise it's not gonna get your inputs. I can press space and you can see the character is jumping. I can press enter and you can see the character is jumping. But movement will be a little bit more complicated. And let me just close everything down to make things easier to understand. Just have the character blueprint open. And now let's start implementing the movement. So again, we can right click here, IA underscore move, use this one, open it up. And in this case, we actually do want to use triggered because whenever the button for walking, the analog stick, is being pressed on every frame, we want to process this and move very little by little on every frame. But first, let me just show you what these axis values, these are the ones that we set up in the IMC that says, okay, it's +1 for right, it's -1 for left. Let me just print these to show you what is actually happening here. So from triggered, I can use print string, so we can have a look at what's happening here and just drag in this action value to the in string. It's going to convert it. And I can start the game. Again, click into the viewport, very important. I press D for right, and you can see whenever I hold the button, we get this x1 value. If I hold left A, you can see we get -1. If I hold W for up, you can see we get -1 on the Y, and for down, I get +1 on the Y. Now let's talk a little bit about why downward is +1 and not -1, which might be weird to you. You can see this coordinate system we have here on the player start, and it is actually quite different from many other game engines. Unreal Engine uses a Z is up left-handed approach, and while in a lot of other game engines the Y-axis would point upward, in Unreal Engine it's the Z-axis that points upward. So you can see the X-axis by default points to the right, so +1 on the horizontal means we go right, -1 means we go left, and you can see here the Y-axis is actually pointing downward towards us by default. So this means +1 on the Y is downward, -1 on the Y is upward. And that is why we set it up this way in the input mapping context. Now let's add the actual movement because we checked the values you get here. And from triggered, I just want to add in add movement input node. You can get it here. And again, this is something that Unreal Engine, you can see the pawn gives us, makes our life very easy. I can Control C, Control V, and copy paste this connected because we want to have a 1 for horizontal and we want to have a 1 for up and down for vertical. And we can specify the world direction. By default, it doesn't know which direction we want to go, but as I said, this one we want to go horizontal, so X, put in 1, and like I said here, X, so this just means we want to go this direction, and we leave the Y and the Z blank. And for this one, we want to control the Y axis, so for Y, put in 1.0, and like I said here, we want to go Y up and down, or rather forward and backward. And all we have to do now is get our axis value here, but we cannot connect it here. We have to break it. So we can break vector 2D, and this then gives us the X and the Y value, which we set up before in our input mapping context. And here for horizontal, we can just connect the X to the scale value. And for the Y, we can just connect it here to the vertical. And we can double click here to get a reroute node. We can select both of these, hit Q to align the nodes, make it look a little bit nicer to look at. And that's it for our movement. I can go back to the map, I click into the viewport, but yeah, I can walk around, we can go diagonal, we can go down, we can go up, we can go in any direction. But even though our character is moving around, the animation isn't changing. We have to now set up the animation blueprint to tell the character, hey, if you're standing still, use this animation. If you're walking, use this animation. And also set up the direction because now it's always just looking towards the camera. Let's now create the PaperZD animation blueprint. In the content drawer, again, we want to go to content, blueprints, and go for kid red. We have to create a different animation blueprint for every character. So we can right click here, go to PaperZD, and use the PaperZD anim BP. And here we have to specify which is the parent animation source because we want the blueprint to be able to access the different animation sequences that we registered on the animation source. So click kid red, and I'm going to call it ABP for animation blueprint and kid red, and double click to open it up. Now we basically have two sections inside of an animation blueprint like this, very similar to skeletal animation blueprints for 3D. We have this event graph, so here we can do certain actions on init, which is similar to begin play, on tick, which is on every frame. So you could do some logic here, you could get references to the character, to different parts of it. But for this tutorial, we're not gonna need it, and we just go to the anim graph. And all we have to do here is set which animation we want to play at which time. And just to get things started, let's drag off here and type in play. And you can see the animations that we registered, the idle, the walk, and also random, which we're not going to use. But let's just try play walk for now to see the difference. And compile and save. And we now need to use this animation blueprint, which we set up inside of the blueprint for our character. So here in the BP Kit Red, I want to go to the animation component. And here where it says PaperZD anim instance class, it has none. We need to select the ABP Kit Red to tell this blueprint to use this PaperZD animation blueprint. And in here, nothing changed. There is no preview that we can see here. But when we start the game, I start here, you can see the character is now playing the walk animation that we set up in the animation blueprint, and it is proving that the connection between the blueprint, the animation blueprint, and the animation source has succeeded, and we now set up the base for what we want to do. Let's now implement the logic to have it decide between playing the walk animation or the idle animation. And we could do a simple select by bool here and put in the logic here, but it is cleaner to create a state machine. So we can just delete this, right click, state machine, and add a new state machine. I'm going to call this locomotion, and then just make sure to connect these two nodes here. And we can then go inside the state machine. And well, the first state that we want to have is the idle, the default state, so animation state. And I'm going to click here. We can rename it, and I'm going to call it idle. And we then want to have the walking state. So drag off here, another animation state. And I'm going to right click to rename, and I'm going to call it walk, just like this. Now we need to specify which animation we want to play for idle and which for walk. So we can double click the idle. And here we just have this output again. So it's kind of a nested system. And here again, I just want to play the idle. So search for play idle, You can set things like the play rate, looping, start position, a lot of different things, but we don't need to set any of that. And we can then go back to the locomotion, and for walk, do the same thing, drag off, play, walk. Again, we don't have to change anything here on the right side, just play the walk animation. And now, yeah, so we have the idle, we have the walk, but we need to set up the conditions. So when do we go from idle to walk? When do we go back from walk to idle? Let's first start with going from idle to walk, and we can double click this transition here. And there's multiple ways we could go about this. We could make it input based, so whenever the button is being held, we want to play the walk animation regardless of if we're hitting a wall or not. But a very common one is to just use the velocity, which is a much simpler method, which we're going to use right now for this video. So what I can do here is right click, get owning, and PaperZD gives us this get owning actor node. So this gives us this BP kid red, and we can access things on this BP kid red, but only as a simple actor, not any advanced things that we set up ourselves. For that, we would have to use casting. But all we need is to get the velocity of this actor. So get velocity, and this basically tells us the speed and the direction, but well, we only care about the speed. So we can get vector length, this. So vector length, and this tells us how fast are we going. And well, to go from idle to walk, we just want to know that we are not standing still. So we can check that the vector length is greater than 0. This means we are walking, we are moving in some capacity. And now if I start the game, you can see I'm standing idle, I click into the viewport and I start walking, and it transitions into the walking animation. This is working. But even if I stand still now, we don't have a transition back to the idle. So let's set that up. And for this, in the ABP, I can just copy this, select everything, Control C, go back to locomotion, and then connect the walk back to idle to create this transition, open it up, and Control V to paste this. And here I can just flip it around. So I say not Boolean, and this just gives us the exact opposite of whatever we set up here. And now I can go into the playground, I can start click in, and if I stand still, I go back to idle. If I walk, I start walking again. So this is the setup we need for switching which animation we use. But we still gotta set up the direction, because now the sprite is always looking away from the camera, but it should face the direction in which we are walking. Currently, it's not just the animation that isn't turning or rotating. Our character itself is also not rotating. The actor itself is not rotating. So to demonstrate that, we can go back to the BP Kid Red. And well, we do have this arrow component, but we can't change it to make it visible. So on the capsule component, I just want to add a new arrow to make it visible to show you what is actually happening here. So go to add, arrow, like this. And we don't have to rename it. I just want to make it twice as big. So arrow size 2. And very important, we can look for hidden in game. And I don't want this to be hidden in game. And we're just going to use this for debugging purposes. So now here, I start the game again, I walk, and you can see no matter which direction I face, the arrow is always pointing to the right. Now what we want is to have the entire actor always rotate towards the direction we are walking. And there's a couple of very simple settings in here. So I don't want to search for hidden anymore. I want to go to the top level, the BP Kid Red, and I want to look for orient. And you can see orient, rotation to movement. And yes, we want to turn this on. But the tooltip is going to tell us this setting can clash with other settings, and we want to change one more setting. And we can look for controller yaw, and we don't want to use the controller yaw rotation. If I go back to the game now and I press start and I walk around, you can see that the character is now properly turning. Well, we have one issue now, that the sprite is turning with it, the camera is turning with it, and all of these things are attached to the actor, so it makes sense, but we want to ignore rotation on these parts. And again, this is very easy. In the BP Kit Red, we can select the sprite and get out of the search. And for the rotation, we can use the world rotation. So this means it ignores the rotation of its parents, which is the capsule component, and it's always just going to keep this specific rotation. So now if I start the game, you can see the camera is still turning, but the sprite is not moving. The sprite is always the same, which is perfect for our purposes. And now we want to do the same thing to the spring arm. On the spring arm, again, just rotation, make sure it's world rotation, and now start the game. And we can see that now the actor itself is actually turning around. You can see the arrows turning, but we are ignoring that rotation. We are ignoring that turning. on the spring arm and we're ignoring it on the sprite as well. And the beauty of the setup is that if we attach something to the actor, like a hitbox, if we want to have a melee attack, like maybe a scene object, if we want to shoot an arrow, shoot a bullet from a certain part of the character, that all of this is going to rotate together with the character, making for a very easy workflow. And most relevant for this project, we can just use the actor forward vector to determine the sprite rotation as well. In the animation blueprint, we can go back to the anim graph, and between the locomotion and between the output, we can add this directionality node. So set directionality. We want to have this in here. I hit Q to align them, and we can give it an X directionality and a Y directionality. Again, what we can do here is we can get owning actor, which again is this BP Kid Red, the instance of BP Kid Red that we are possessing. And well, we can get actor forward vector. So this will always give us the direction where the arrow is pointing. And this is very helpful for figuring this out. But one problem we have now, we have a vector 3 and a vector 2D. So these are not compatible. We could auto-convert them, but we actually want to do this manually. So I can right-click here and split, and I can right-click here and split. And for now, we just connect the X value. There's nothing we have to change here. And this is already gonna work. So I can go to the map, start, I press left. You can see once the arrow turns above the middle, we can go left and right, and it's gonna turn correctly. Up and down, we still haven't connected, but left and right is working like this. Now, if we just connect the y-axis, let's see what happens. There's gonna be a small issue like this. And if I go up and down, it is actually turning the character in the opposite direction. And why is this happening? Again, it is related to Unreal Engine's kind of weird Z is up left-handed coordinate system. Even though for 3D objects in the world, the Z-axis is up and the Y-axis is forward and backward, in a 2D space, such as this PaperZD context, the X is left and right and the Y is actually up and down because the Z-axis doesn't exist. And this isn't a bug or anything, this is also the way it works in Unreal Engine's widget editor, so you kind of have to convert between these two different coordinate spaces. And in this case, it's very easy, we just have to multiply the y by -1. So this is gonna invert it like this. Just open up some space. This is gonna solve all of our problems. We can start here, and now I go up, the character is pointing upwards, I go down, pointing downwards, and I can walk in all of these different directions. And all we had to do is to make sure that the conversion between the 3D coordinate space and the 2D coordinate space is being fixed by inverting the y-axis here. Now that we're done with this part, we can get rid of the arrow. So here the arrow, we can just hit delete on the keyboard, get rid of it, and walk around, and everything is still working. But we do want to make some adjustments to the character movement now. We can make changes to how fast the character is rotating here, because you can see if I go from left to right or right to left, it takes roughly half a second for a half turn and 1 second for a complete turn. Inside of BPKitRed, we can go to the top level and we can look for rotation rate. And again, this is something that just comes with Unreal Engine, right, with all the systems we get. And you can see on the Z, we have the rotation rate of 360, which means in 1 second, we turn by 360 degrees. If you want it to be super snappy and instant, we could just multiply this by 10, for example, right here, do the math right here, and now you get very snappy, very fast changing of directions. And well, this depends on your preferences, what you want to do with your game. But I actually do like the smooth and slow turning, so I'm going to go back to 360, and you can play around with this value to find whatever you like. Next up, the character movement is a little bit fast. By default, it's 600 centimeters per second, and I think that is a little bit fast for this kind of game by default. So in the Kid Red, I can look for max walk speed. So max walk speed, 600 centimeters. I want to change it to 400 centimeters per second, like this. And now the character is walking a little bit slower paced. And you could then, for example, create a bicycle, maybe create different shoes you could get, which then change the value here so you can run faster or slower. Lastly, the jump is a little bit floaty. So you can see the jump jumps very high. It takes a long time for us to reach the ground again. And I want to quickly change that. So here in the BPKitRed, we can look for gravity and change the gravity scale to, let's say, 2.5 to make gravity affect us 2.5 times as much. And this makes the jump very snappy, but we can also make it a little bit higher to compensate for that. So we can look for jump Z, velocity, and let's just say 500, make it a little bit higher. Go here. And now I like this jump a little bit more. And you can again play around with these values to find what you like. And sadly, we don't have a jump animation for this character, but just having the walk animation play briefly actually kind of doubles as a small jump animation, and it doesn't look too awkward. Next up, I want to do some adjustments to the project settings. Some of these aren't as apparent, but I think you can already tell that if we walk around, the shadow gets very blurry and it doesn't look nice. We want to have a crisp shadow, and this is due to motion blur. There might be a way to make motion blur work in these 2D 3D hybrids, but generally it's going to cause issues with the sprites, it might cause ghosting, we don't want to use it. And we can go to Edit, go to Project Settings, and we can simply search for motion blur and just turn it off. And this instantly fixes the issue. The shadow is now crisp, and this also makes sure we don't get any motion blur based ghosting on our animations. The next setting we want to change is anti-aliasing, and with this character it's not very apparent that we have issues right now because we have a static idle animation, but in a lot of the other games I made you would get really strong ghosting between the animation frames. Let's go back to the project settings and just look for anti-aliasing. And here, not the mobile, but the default settings here, anti-aliasing. By default, it's using temporal super resolution or TSR, which is the newest, most modern version, but it also comes with a very high performance cost. And usually just changing from this to another method gives you a 20% performance boost, roughly. Another method that a lot of 3D games use is TAA, so temporal anti-aliasing. But again, this could cause ghosting, especially for sprites. So when working with sprites, we generally want to avoid anything with temporal in the name, because this accumulates data over multiple frames. And unlike skeletal meshes, sprites don't output motion vectors, so there's no way for the system to compensate for the rapid changing of animations. Multi-sample anti-aliasing only works with forward rendering active, and you might want to use forward rendering for a 2D 3D hybrid, but it gets rid of a lot of features that we have on by default now, so that is an advanced thing that I'm not going to get into in this beginner tutorial. So we're going to stay on the forward rendering, and this only leaves us with none or FXAA, fast approximate anti-aliasing. We could go with none because we don't need anti-aliasing on our sprites, but we do want to use anti-aliasing on our 3D backgrounds. So FXAA is actually the best solution in my mind because we do get some anti-aliasing on the 3D backgrounds and it doesn't interfere with our sprites, it doesn't cause ghosting. Next up, we're going to look at the global illumination or lumen setting. And to demonstrate this better, I want to place a cube in the level. So go to Shapes, go to Cube, and I want to drag it around here a little bit, drag it here, and make it a little bit bigger. So go to Scale Mode, and just drag it here, and rotate it slightly like this. And now if I start the game, you can see that now my character is in the shading, but if I go behind this block, you can see the characters lighting up, right? It's very subtle, but this means that light is bouncing off of this block and is bouncing onto my character sprite. And just to make this stronger, let me make this block even bigger, like this. And yeah, you can see the characters in the shade. I go here, and we get this bounce lighting to light up the character. And this is something you might want to use, right? Dynamic global illumination like this can be very cool, but it comes at a high cost. And I think for these 2D 3D hybrids, it's usually not worth it. So if you want to use Lumen, you should know exactly what it offers and you should make the best use of it. Otherwise, follow along and turn it off. Again, in the project settings, we can look for global dynamic illumination like this and turn it from lumen to none. And the same for reflections. We can go to reflection method, and go from lumen to screen space reflection, which again is a little bit better for performance. But again, it's up to you how you want to use it. This is just, I guess, the defaulty go-to I suggest. And if I start the game now, you can see everything is a little bit darker and I don't get the bounce lighting here from this block. So it makes it look less realistic, but we usually save 20-30% of performance, if not even more. And like I said, there's many more other settings being covered in my course that I just can't fit into this short beginner tutorial. And now I just want to showcase the coolest part, which is putting this character into a map from the marketplace. Make sure to save everything, so File, Save All, or use the keyboard shortcut, and then open up the Epic Games Launcher and your library. So if you've been using Unreal Engine for a while, you should probably have a couple of maps in here. And since I haven't found a single map that is specifically made with pixel textures, what we're looking for is stylized maps, which is, I guess, the best thing we can get. So we can just look for stylized here, and you should probably have a couple of maps here. If you don't, a couple of these are actually free permanently. So you could go to Fab, you could grab this stylized Eastern Village, you could grab stylized Egypt. These are permanently free, but I'm gonna try a couple of different ones as well. I'm actually gonna go for this Tokyo stylized environment, which was a free asset, but you can just use whichever one you have available. And I wanna add it to the project, and here, just make sure to show all projects because it hasn't been updated to 5.5 yet, and use our hybrid top-down project. It's gonna yell at you, tell you which version you wanna use. Well, 5.4 is the closest to 5.5, and I'm just gonna add this to the project. And even while Unreal Engine is open, the map has been added here, content, in the content folder, and whatever the name of your map is. In my case, Tokyo stylized environment. I can go to maps, and it should have a map, not the asset overview, but some sort of demo level is required to list your map on the Unreal Engine marketplace. And it's going to take a little bit for shader compilation. And as long as the map has a player start somewhere, everything should work. You can see we have a player start here. I just press play. All of the settings, everything we set up works with this map right now. And I think this looks pretty amazing. There's of course changes we could do here, like changing the texture resolution on the textures in the map to make it look more pixelated. You could also go in and hand edit some of the textures to better fit this 2D 3D hybrid look. But as a starting point, stylized maps usually are pretty good. And this is all you need to get you started on your journey of making 2D 3D hybrid top-down games in Unreal Engine. And of course, there's a lot of details to get into, but this is a short beginner tutorial that should give you a starting point. And again, if you've enjoyed this tutorial and watched it till the end, I'm pretty sure you're gonna love my 17-hour course teaching you how to make 3 different 2D top-down games in Unreal, with 2 of them being true 2D top-down games, and the last one being a 2D 3D hybrid, similar to Octopath Traveler, Dragon Quest, and these types of RPGs that are gaining a lot of popularity recently. So make sure to get it at a discount from the link in the description. As always, thanks to my awesome patrons and YouTube members.